Okay, so I created this example to help us learn rotations better. This is the second installment of the rotations, and what I want to focus on here is, you know, figures that have more than one point. Makes it a little more complex. It's going to make the diagram messy. We're going to have to do the work on a separate sheet of paper and then transfer that back over and explain it on the final copy. So we'll have scrap graph paper available on tests, and you'll have to use it. So when it's multiple points, such as this figure, we'll get even into some triangles. It gets really messy. We're going to rotate 90 degrees, and then our center is at the origin. So the center we're going to call O for origin, center of rotation. So rotations have a center and an angle measure we got to follow. So the center is going to be 0, 0. You're going to hear me say origin sometimes. We're going to label it O. Typically for origin. All right, not always, but that's what I'm going to use. So when I rotate, I think of it as a circle. The point A is going to follow a circle. Okay, trying to draw a circle here, that's going to be hard, so I'm not even going to bother here. But I want the center of the circle to be O, and it's A is going to follow that circle. Now, I'm going to use geometry concepts when I do these. The geometry concept when we're on a graph, okay, to get 90 degrees on a graph, we're going to use slopes are negative reciprocals. You have to use the right geometry concept for the right situation. So 90 degrees on a graph, I'm going to use slopes are negative reciprocals. That means switch the sign and flip the fraction, okay? So we'll see that. What I have to do is I have to, oops, sorry about that. I have to go from O to A. I've got to calculate that slope. Because what I have to create is I have to create a 90-degree angle between the angle A to O to A prime. That measure has to be 90 degrees. And to do that, I'm going to use slopes or negative reciprocals. All right. So the first thing I'll do now is I will calculate O to A's slope. So O to A has a slope that looks like a run of 6, a rise of 2, and it's positive. Whoops. A run of 6 goes on the bottom, a rise of 2 goes on the top. I'm not going to reduce it. The reason I don't reduce it in this case is because we have to use the same movements. So we're not going to reduce. Okay? Now, O to A prime has to have a slope that is the negative reciprocal. So there's flipping the fraction and changing the sign. It was positive. We're going to make it negative. Okay? Get that on there. All right. So from O, what I have to do is I've got to go down 6, right 2. That's what this means. That's one way to get a slope of negative 6 over 2. I'm going to do that. 1, 2, 3, 4, 5, 6, 1, 2 from O. Now, if I do that for A prime, I've just gone in the wrong direction. I want 90 degrees. We talked about it in the last installment here. You've got to go in a counterclockwise direction unless they tell you otherwise. Well, how do I fix that then? This didn't work. Well, an equivalent is up 6 but left 2. That's an equivalent. Let's try that. Up 6, left 2. If that's A prime, that's going to take me in the correct direction. That angle is going to be 90 degrees. That's its location. Okay. So now I know A prime's location is going to be at negative 2, 6. All right, for B prime. Now, this is why we need scrap. Okay, it's going to get too messy, so I'm going to erase that. Okay. We can leave that there, though. Negative 6. We can leave A prime there. Now, same concept for B. Let's use a different color here. So from B to O, okay, got to be a little careful here. I'm going to have a 1, 2, 3, 4, 5, 6 for the run, 1, 2, 3, 4, 5 for the rise. All right, same concept. So for O to B right now, my slope is a run of 6, a rise of 5. For OB prime, I'm going to need a slope, flip it, and change the sign. So from O, I have to go negative 6, 5. So that means down 6, right 5. Or an equivalent, again, we know that's wrong because it's in the wrong direction, or we could go, so instead of down 6, up 5, I'm sorry, down 6, right 5, let's switch them both. That's equivalent to up 6, but left 5. Let's try that. Up 6, left 5. Here's where B prime would be. All right, that's a little weird. That's at negative 5, 6 is the location. Okay, and if you connect those, does it really look like what happened, what we thought was going to happen, happened? All right, let's put A prime here. Let's get rid of some of this other stuff, and we can observe real quick. Get rid of all these dots. Does it look like, okay, does it really look like we turned this paper centered here? It went from a vertical to a flat. Is that really a 90? 90-degree move there, looks good. That looks like a 90-degree move there. And that's what it's going to look like. A little strange, but that's what we have to be able to do. Okay, we'll try another one. Okay, next question. Just pause and look at this for a second. Some key ideas here. The center of this rotation, the center, we're going to call it P this time, is at 5, negative 2, a little strange. And our angle of rotation is going to be negative 90. Now, wait a minute, what does that mean? Well, it means a quarter turn, but to the backwards. So we're actually going to go, and we're going to actually go, instead of our typical counterclockwise direction, we're going to go clockwise. Okay, so let's put our center down. Okay, there's P for our center. Let's go graph these other points quick. C is going to be at 5, negative 5, 8, negative 5, and 5, negative 7. Okay, so that's going to be C, D, and E. Okay, so it's going to look like this. Full-on triangle. This is where it gets a little bit messy. So I would go off on scrap paper to get the coordinates for each point, one at a time, and watch this. I know that's tedious, but that's what's got to be done. So I have to think to myself, okay, to find C prime, right? What's the concept? Well, I need the angle C to P to C prime to equal 90 degrees. How do we do that on a graph? On the graph, we need slopes to be, for 90 degrees only, slopes must be negative reciprocals. All right, so that's, again, the same concept. That's never going to change, and we do that in a lot of cases. Now, here's what's great. For the slopes, right now, of C to P, okay, the slope is undefined. I'm not going to count because when it's vertical like this, well, we can count. It's up 3, so the rise is 3, the run is 0, right? We should use the same number, so then C prime to P, well, that must be a 0 slope. Undefined and 0 are going to be perpendicular. Doesn't follow this negative reciprocal idea, but that's what's going to happen. Now, what I want to do is I want to use the same numbers. So the rise is going to be 0, the run is going to be 3. Okay? So I'll either go 3 to the left from P or 3 to the right. And that's a decision you've got to make, right? We're going to go rise of 0. So I'm either going to go, obviously we're going to go up or down 0. We're going to go either left 3 or right 3. Doesn't make any difference. Okay? So we could switch it down 0, left, or right 3. Doesn't matter. So, but now we got to pick. All right, which one is going in the direction we're supposed to? Negative 90, see, is supposed to go in the negative or clockwise direction. So we have to fix this. Which one does that? Well, it's going to be this one. Okay, so that's going to be C prime. What you're going to get for a location, you're going to have to do one at a time. You're going to look at 2, negative 2. Okay, now we're going to have to erase or go to a different graph because it's just going to be in the way. Okay, so on another graph, what we're going to do is we're going to now go for D. Okay, so what do we need? All right, we're going to find D prime, right? And what's the idea? Well, we need angle D to P to D prime, the measure to be 90 degrees. That's what we need. Again, we're going to use slopes that are negative reciprocals. So let's calculate the slope of D to P. All right, so from here to here, we've got a rise of 3 and a run of 3. Okay, and it's negative. Why is it negative? Well, it's going down as we move left to right. So for perpendicular, right, D to P prime, sorry, D prime to P, we got to flip that fraction, so same numbers, but instead of a negative, we're going to make it a positive. Okay, so go to P and count either up 3, right 3, or down 3, left 3. That's your positive, that's your slope that's going to be positive 3 over 3. So we start at P, check this out. I'm either going to count up 3, left 3, it's either there, or I'm going to count down 3, left 3. Oh, I'm sorry, I messed up the first one. Sorry. I said up 3, right 3. It's one of these two. I apologize. So from P, right, we either have to go up 3, right 3, or we have to go down 3, left 3 to find the new location for D prime. Now, if this is D, and we have to move in this direction, we're going to pick this one. Okay, so that's going to be for D, we're going to get 2, negative 1, 2, 3, 4, 5. So D prime is going to be at 2, negative 5. This is hard. I get it. And then we'll put it all together in one graph and you'll see it. Okay, let's get rid of it. New graph. This is hard, but we'll do it. Now we got to take a look for E. E, luckily for us, is 1, 2, 3, 4, 5 from P. 5 up. So we have to get for E, right? E to P, right? The slope is undefined. And to get it exact, you're looking at up 5 over 0. To be perpendicular to EP, we need E prime P. The slope needs to be 0. That's the perpendicular slope. So why don't we try flip it, 0 and change the sign, right? So that's either an up, sorry, it's either a down 0, right 5, or an up 0, left 5. Let's try that from P. What did I say? We're going to go down 0, right 5. 1, 2, 3, 4, 4, 5. Okay, so it's either going to be there. Get rid of this guy. So we either have to put E prime there, or what did I say? Left 5. Up 0, 1, 2, 3, 4, 5. Let's figure it out. E prime is one of these two locations. If we are at E, that's our center, moving this way, 90 degrees, that's the one. So that's going to be at 0, negative 2. So E prime is 0, negative 2. Now we go back to our nice graph, clean graph. Okay, and now we'd actually plot this, and you're going to see what happens. So let's plot the points we just wrote down. 2, negative 2, 2, negative 5, and 0, negative 2. And this is going to be C prime, D prime, E prime. Does it actually look like we took this figure and we turned it 90 degrees, centered at that point? hopefully you can see that that's what happened. Very difficult rotations, either positive or negative direction. It's going to be a lot of work, all right, but persevere through it and you'll be able to do it. All right, thanks so much for tuning in, and good luck.